Well, you would expect there to be more heat waves and prolonged hot spells if it's warming. That's sort of obvious. Although what's perhaps not obvious is why those heat waves and prolonged hot spells should rise dramatically if the temperature on average changes only like a degree Celsius or something. Well, I'll show you in a later lecture exactly why that's the case. It's the same reason, by the way, that I showed some of you in my video course, Physics in Your Life, about why food spoils in the refrigerator if the temperature goes up only a little bit. It's the same phenomenon. A very small change in the average temperature can dramatically shift conditions at the extremes. And so we expect to see more extremely hot days and more heat waves. Precipitation is changing. The patterns are changing, and in particular, the precipitation globally seems to be increasing. There's a slight increase in precipitation, but some areas are drier. That change is not even. So some areas are getting drier, and some areas are getting warmer. Some areas are getting wetter. There's more precipitation coming in brief, intense events. That's another characteristic fingerprint of anthropogenic climate change, and we're definitely seeing more precipitation coming in brief, intense events. And if you think about that, you might say, well, if you were a plant or if you were some soil that was going to erode, how the precipitation comes, a gentle rain that lasts an hour, a brief downpour that lasts 10 minutes, that makes a big difference even if the amount of rainfall stays unchanged. So here's a more subtle change in what's going on, and that's a change that, again, is a fingerprint of anthropogenic climate change. And there's pretty substantial evidence that we are seeing more precipitation coming in brief, intense events than we used to. And again, there's evidence that we are seeing more precipitation generally globally, not a whole lot more, but more. And we are also seeing some parts of the world drying out and some parts getting wetter. Another thing that's changing is the diurnal temperature range, what climatologists call the DTR, the temperature difference between night and day, and that's decreasing. It's actually warming more at night than it is in the daytime. That's causing the temperature range from night to day to decrease. That's probably associated with increased cloudiness. In my home state of Vermont, there's a big worry about that because maple sap production requires very cold nights and then warm spells in the day. And if we lower the diurnal temperature range, we don't get those conditions. And in fact, the maple syrup industry may leave my state for Canada as a result of global climate change. We've heard a lot about hurricanes in recent years. And we've heard a lot about whether hurricanes may or may not be related to global climate change, and there the issues are quite subtle. There are definitely some changes in hurricanes, and I'm going to show you another graph. This is a graph that is associated with the North Atlantic and with the intensity of hurricanes as measured by an average of the actual power contained in the winds of the hurricane multiplied by the time over which those winds were blowing, which gives you a sense of the sort of total energy contained in the hurricanes, and that's done over a whole hurricane season. And this graph shows you two curves. The lower curve is the sea surface temperature in the North Atlantic. The upper curve is the hurricane intensity as measured, as I just described, by that total energy associated with the power contained in the winds multiplied by the time over which those winds were blowing. For those of you who are mathematician types, by the way, that power in the wind goes as the cube of the wind velocity. That's because kinetic energy goes as the square of the wind velocity, and therefore the wind is carrying that kinetic energy along at its velocity. So the whole thing goes as the cube of the wind velocity. So if you double the wind speed in a hurricane, the intensity of that hurricane goes up eightfold. And here you see, in the North Atlantic at least, quite a clear correlation between the intensity of the hurricanes and the sea surface temperature. And there's plenty of good reasons for expecting that warm sea surface is what drives intense hurricanes. So that's not surprising, and that seems to be something that's related to climate change. Now, in the interests of scientific accuracy, I will tell you, if you do the same thing, and it has been done for other ocean basins, the correlation is less dramatically obvious. And one thing that is not at all obvious is whether to expect an increase in the number of hurricanes or whether, in fact, we've seen an increase in the number of hurricanes. It's pretty clear we've seen an increase in their intensity, but have we seen an increase in their numbers? These things are a little bit harder to get at than you might expect. So something like hurricanes presents a kind of an ambiguity for us. We can get at some aspects of hurricanes that may be related to climate change, but hurricanes are subtle, and we don't know all the details. And finally, let me end with something related more to life itself, and that is what happens to species. and that was the butterflies in the title of this lecture. What happens to species as a result of climate change? Well, a lot of things happen to species. Species undergo a lot of behaviors that, in fact, are related to timing of when the spring arrives, what the highest temperatures are, when the first frost is. Things like that affect plant and animal species both. And the results I'm going to talk about here are from not one study of a particular species of butterfly or bird or tree, but rather of a meta-study, so-called, that looked at hundreds and hundreds of studies of individual species and came to kind of general average conclusions about what was happening. So what do those species do? Well, in the northern hemisphere, on the average, species seem to be moving northward. Their ranges, the southern extent of their range and the northern extent of their range, seem to be moving northward at about 6 kilometers per decade. So every 10 years, if you take a species whose southern range was New York City or something, then 10 years later, its southern range is 6 kilometers, about 4 miles north of there, and the same goes for the northernmost range. And again, this is not about any one species. It's kind of an average over many, many species. But there you are when you do that average. Mountain species that live in high altitudes, tend to be moving upward. That's the only way they can move easily. They're moving upward at about 6 meters per decade, so 6 kilometers per decade roughly for the species that are moving toward the poles, and 6 meters per decade roughly for the species that live on the mountains. Other events, spring events, seem to be taking place earlier by roughly 2 to 3 days for every decade. So every 10 years, a lot of events that you think of in spring move earlier. And I know, having lived in Vermont quite a while, I used to plant my tomatoes on Memorial Day. Now I plant them in early May. That's an example of that kind of spring events moving earlier by 2 to 3 days per decade. You can see it's not always a bad thing. Some of those events include nesting, when birds build their nests, when animals breed, bud burst, the bursting of buds to make leaves, when things flower, or when the spring migration ends. All those things are happening earlier by about 2.3 days per decade. So there are some other examples of things that species are doing that are varying. Now I want to emphasize that something as complicated as the behavior of a plant or animal species is not determined solely by climate. There are other factors. What are other species doing? What are the prey or the predator species doing? What are diseases that affect that species doing? There are all kinds of other effects. These are subtle scientific questions, and that's why this meta-study of hundreds and hundreds of different species gives us a sense of what's happening. Overall, we don't expect every single species to be doing that. In fact, if you look at these meta-studies, you will find that roughly 87% of them have changes that are consistent with what you'd expect if those changes are driven by global warming. A small fraction of them, species whose behaviors may be dominated by things other than the actual warming associated with climate change. Maybe they're affected by precipitation, maybe they're affected by other species. This is not surprising. About 13% of species in this meta-study of hundreds of species have shown changes that are in the opposite direction than you'd expect associated with a temperature change. And that's simply an indication that what controls the behavior of a species is a lot more than climate alone, and that's not surprising. But the main point to take away from these studies is that of the species studied, 87% showed changes in their behavioral range, their mating behavior, their early spring behavior, their migrations, etc., that seem to be consistent with global warming, and only 13% showed changes that bucked that trend. Well, let me end by summarizing what we've seen here. We've seen a whole lot of fingerprints for global climate change in a whole lot of different areas. The temperatures in boreholes, measuring the temperature down into the earth and indicating that historically there's been a flow of heat into the earth, and therefore the temperatures are rising abnormally near the surface, not abnormally, but are rising at the surface. They're rising, there's a change in the temperature occurring. We've seen the heat content of the ocean rising. We've seen the atmospheric temperature rising in the lower atmosphere, but falling in the stratosphere, which is something, as you'll see in a few lectures, is exactly what we would expect if there was greenhouse effect global warming. We've seen changes in the cryosphere, which are largely associated with melting and shrinking of polar ice, mountain glaciers, ice caps, and so on. And finally, we've seen changes in the behavior of species with respect to the ranges they occupy and with respect to the timing of characteristic behaviors like mating and nesting and bud burst and so on. There are many fingerprints that point to the fact that Earth is indeed warming, that the climate is indeed changing.